if this is velocity time graph, if this is the one drawn as a line through origin, if a line is drawn through origin as a velocity time graph, then we can say this is it. It shows the motion. It shows the motion of a particle. It shows the motion of a particle moving with constant acceleration, starting from rest. If this motion is to be explained, here I can see the slope of the graph is constant, since slope is m, that is decided by tan of theta, right. So in velocity time graph, slope is equal to value of acceleration, right. Slope of Vt graph will be the value of acceleration. Got my point? So as because this, whenever a straight line will be drawn having constant slope, that does mean in Vt graph relation, that constant slope will represent the constant acceleration. So here also the straight line with a constant slope, as I said that in case of a motion of a particle moving with a constant acceleration will be the one where slope will be constant. That means we can come to know this thing, that whenever a velocity time graph will be plotted by a straight line, so long as the line will be straight, that means so long as the slope is maintained same, right, till that time we can say the particle is moving with a constant acceleration. As because the initial y coordinate and x coordinate both are 0, that means particle is starting from rest, initial velocity 0 at t equal to 0, isn't it? So that's why I have written, this is showing that the motion of a particle moving with constant acceleration starting from rest. Is that okay? Now in velocity time graph only, if I draw the straight line like this time you can see, this time again you can see slope is constant, but the initial velocity is having some u value at t equal to 0, right. At the starting t equal to 0, particle is having certain velocity. So here in this case we can say it shows that a particle starts with initial velocity of u meter per second and having constant acceleration of value a equals to the numerical value of tan theta, whatever we can get it, provided theta is given. Are you getting it? So whenever we draw the straight line, provided particles begins with an initial velocity starting from rest, so its drawing will be like this. Okay, are you getting it? For example, if I draw another graph where still it is the velocity and y, time on x axis, suppose the graph is shown like this. This is the origin 0 0, but particle is starting with some negative value of velocity. Let it is t equal to t naught is the time where it is intersecting the time axis. What does it mean? What you would like to say about this graph? Can you tell me? What would you like to say about this graph? What kind of motion, what will be the characteristics of motion that we can say about this particle which starts from this point intersecting the time axis at t equal to t naught, and after that velocity part will be positive after t equal to t naught. What would you like to say about this? Here I can say that it shows about a straight line motion. It shows about a straight line motion where at t equal to 0 initial velocity was negative, that is minus u meter per second, and having constant acceleration throughout the motion. Constant acceleration throughout the motion means from t equal to 0 to t equal to t naught second, from t equal to 0 to t equal to t naught second, instantaneous velocity and acceleration were opposite in direction. Are you getting this meaning of this sentence? Are you understanding the meaning of this sentence if I am saying that starting from t equal to 0 to t equal to t naught second, the velocity value was negative and acceleration even before t equal to t naught, see, slope everywhere remains positive, yes or no? If you want to see the slope of the curve after t equal to t naught, then also you can see theta slope will be decided by tan theta. Even for t equal to 0 to t equal to t naught, everywhere if you want to check the slope value, that also same, the value of tan theta before t naught and after t naught, in both cases the slope remains same, means acceleration value remains constant and positive in between t equal to t naught as well as after t equal to t naught.